So now we're going to move on into learning how to graph graphs using different methods. So right now we've only learned how to use the table method, but now you're going to learn another way of graphing today. And it's up to you whenever we take this test of which method you think is best or easiest for you to use. And it doesn't matter how you graph this as long as if you know how. Different forms and different methods are easier depending on the way that the question is presented to you, but ultimately it is up to you. So we're moving on to our third unit, so unit 2C, our third section of the unit, and we're going to be now learning about slope-intercept form. So remember, at the end of the video, our learning objectives, you should be able to come back to these and say, do I know how to do these? Or do I need to ask more questions about this? So students will know how to write and identify an equation in slope-intercept form. So we're going to learn how to graph in slope-intercept form. And you also need to be able to identify, well, what is slope-intercept form and how is it presented. Students will know what a y-intercept is and how to identify it in an equation and a graph. So if you're going to graph, you'll be able to know, have to know how to be able to plot it and also identify it. And also you'll have to be able to know how to identify it from an equation as well. And students will know how to graph an equation when given the slope and the y-intercept. And that's why this is called the slope-intercept form, because you're given two things. You're given a slope and then you're given a y-intercept. And from there, you can go ahead and graph pretty easily, actually. So the slope-intercept form is y is equal to mx plus b. And we should already know what the letter m stands for because in our last video, we learned about our slope. So we know that this m is going to represent our slope as we talked about m representing slope. We know our x and our y's are just our points, x and y. So that means the last thing here that we have is this plus b. And that is actually our y-intercept. Right? That is how it is identified within our equations. And that is something that you will have to be able to identify. And if you notice, the slope is being multiplied to our variable x, and the y-intercept is just what's being added or what's being subtracted to it at the end. So it's our constant in this equation. Our slope, m, is being multiplied to our x, so it's the coefficient of our variable x. And that b, our y-intercept that you'll have to be able to identify, is the constant. All right, so let's go ahead and before we get into actually graphing or talking about this a little bit more, I'm going to show you some graphs to see if you can identify what our y-intercept actually is. All right, so I'm going to go ahead and give you some graphs here. You see we have them off to the side. We have y is equal to x plus 1, y is equal to x plus 3, y is equal to x minus 1, and y is equal to x minus 3. And we're trying to identify if you can identify what our y-intercept is without me really needing to tell you right now. So let's go ahead and look at our first graph. So y is equal to x plus 1. So remember, this line here, this black line that ranges from -4 to 5 is our x-axis, our horizontal line, and our vertical line is our y-axis. So you see it says y is equal to x plus 1. And look at this graph and see maybe if you can identify what our y-intercept is, or maybe what it could be representing. Because remember, it's the constant that's being added by itself. So let's go ahead and look at this y is equal to x plus 3. So when we look here, we see, okay, here's our blue graph of y is equal to x plus 3. So once again, maybe you can identify what this means, our y-intercept. So if you can, you should predict now where you think this line is going to cross this y-axis at y is equal to x minus 1, and where y is equal to x minus 3. All right, so our y-intercept is where our graph crosses our y-axis. So you see here where it said y is equal to x plus 1. Well, our red graph, it's where it crosses at 1. So our graph crosses in our y-axis at 1. So it's intercepting our y-axis at this 1. Our y is equal to x plus 3. You see here it crosses at this 3 where our y value is 3. Y is equal to x minus 1. It intercepts or crosses at our minus 1. And minus 3 here we have at -3. And one of the things you have to be aware of is our y-intercept. What is our x value when our graph crosses that y-axis? So here we know that this is our origin, 0, 0. And if we don't move anywhere left or right, our x value never changes its value, so it still remains 0. So one of the things you have to be able to identify as well is not only is it that our y-intercept is where it crosses our y-axis, but also our x value is equal to 0 at that point. All right, so we're going to come back to this one later on. We're not going to discuss this in this video right now. We're only going to focus on our y-intercept. So our y-intercept of a line is the y-coordinate of the point where the line crosses the y-axis. It occurs when x is equal to 0. So you see here at our y-intercept, they're labeled by that letter b, because as we talked about already, that's part of our equation, our slope-intercept form. And our point is equal to 0 comma b, so whatever that value is, that's where we cross our y-axis, and our x value is always going to be 0 for that. All right, it's really important that you understand this, not right now necessarily, but in our next video and the next way that we learn how to graph, it's going to be super important that you understand these intercepts even more. But our slope-intercept form is a linear equation written in the form y is equal to mx plus b. So that is how we know something is in our slope-intercept form, because it's giving us our slope and it's giving us our y-intercept. So we're not trying to confuse you with the name of this. It's literally telling you the information that you have. Our slope is our n and our y-intercept is our b. All right, and now we're going to go ahead and identify our slope and our y-intercept first, and then we're going to go ahead and use this to graph. All right, so for this problem, all you're asked to do is just find the slope and y-intercept of the graph of each linear equation. So here's our equation, y is equal to negative 4x minus 2. Remember, our slope-intercept form is y is equal to mx plus b. The coefficient of our variable x, so the number that's being multiplied to our x, is our slope. So in this case, when I see I have negative 4x, well, the coefficient is negative 4. That's what's being multiplied to our x. So that means our slope is equal to negative 4. And then our last one, our b, our y-intercept, well, that is our constant that's either being added or subtracted to our variable x. So if it's minus, that means it's a negative y-intercept. If it's positive, that means it's going to be a positive y-intercept. So the sign stays with it. So since it's minus 2, our y-intercept is negative 2. All right, so we can look at this as a point of 0 comma negative 2, because our x value at our y-intercept is 0. All right, so you must be able to identify it, because when we go to graph, it makes it so much easier when you can identify these. And if you can't identify it, you won't be able to actually solve. And if you recall, our last unit, I told you that it's going to be important for you to be able to rewrite equations so y is equal to. So when we have our slope-intercept form, it must be set equal to y all by itself. So if this was 5y, we would have to divide by 5. So it's y is isolated just all by itself, like we were doing in our last unit. All right, and now we're going to go ahead and graph 2 problems, and that'll be it for this video. All right, so for this, we're going to go ahead and graph. And the way that we can graph this using our slope-intercept form is, first we need to identify where our slope is and identify what our y-intercept is. So when we look here, we see y is equal to negative 3x plus 3. Remember, it's y is equal to mx plus b. So our coefficient of our variable x, whatever's being multiplied to it, is our slope. So it means it's negative 3. So I'm going to go ahead and say our slope is negative 3. But I'm going to rewrite it as negative 3 over 1, because we know that this represents our change in y over our change in x. So I'm going to write it in that fraction form so it reminds me of what my change in x is. If you don't have that written, maybe you might forget. And then we know that our coefficient of what's being added or subtracted is our b. So that means our y-intercept in this case is equal to 3. And I'm going to go ahead and write this as 0 comma 3. So now, one of the things that you will learn in geometry when you guys take that next year is that in order for you to draw a line, all you need is 2 points. So through any 2 points, you can draw one straight line. I'm going to have you plot a minimum of 3 points, so that this way you know that you're not making any mistakes. So the way that we do this is, first we graph our y-intercept. So our y-intercept here we know is 3, so it's a point 0 comma 3. So I'm going to go ahead and plot that point 0 comma 3 of where I'm crossing that y-axis. And then from here, I'm going to use this slope to generate 2 points. I'm going to go in both directions. And remember, we can rewrite it, our change in y over change in x. I can rewrite this as negative 3 over 1 as my slope. And I can also rewrite it as 1 over negative 3. So I can do it in both directions. So I'm going to go ahead and graph this going in both directions. My first one, my change in y will be negative 3. So I'm going to count down 1, 2, 3. So I know my next point is going to be somewhere along here on the x-axis. My change in x in this case is 1. So I'm going to go into one positive in one direction. So I go down 3, 1, 2, 3, and then I went over 1 to go to that next point. Right? And then I'm going to plot another one in the other direction, just so that this way I know I didn't make any mistakes. You could keep plotting it in the same direction, but if you miscalculated your slope on this first one, you won't realize that you made a mistake maybe. But if you did it in the other way and you don't get a straight line, and you know you made a mistake somewhere, it's just a way for you to check your work. So in this one, our change in y is positive 3, so I'll go up 1, 2, 3. So now I know my point is going to be somewhere here along our value of where y is equal to 6. And then from there, I'm going to the left 1 because now I changed the negative to go in the bottom. So that means I will go up 3 and over 1, and there would be my next point. And now I'm going to go ahead and draw my line. You guys will use a straight edge. For this, I just need to go ahead and use here. It's not as good as what you guys will have when you're actually drawing your real points, but that is my graph. Right, and that's what your graph would look like. So it's actually not too bad when you're plotting. It's actually faster and easier, I think, than creating the table method. But it's important that you guys can understand and rewrite your slopes in different ways and understand that what your y-intercept means, or otherwise you can't use this method. All right, there's one more, and then that'll be it for this video. All right, so for this one now, remember we have y is equal to mx plus b is our slope-intercept form. So our slope is whatever is being multiplied, or the coefficient of our variable x, and in this case, it's 3 over 2. So my slope is equal to 3 over 2. And in my y-intercept, it is whatever is being added or subtracted. In this case, our constant, in this case, it's minus 4. So my b is equal to negative 4, and I know that this will have a point of 0, negative 4. So the first thing I'm going to go ahead and do is I will go ahead and plot that y-intercept, because then it gives me my starting point of how I can apply my slope going forward. So I know my y-intercept is there at 0, negative 4. My slope is 3 over 2. So remember, I know that this means my change in y over change in x. And right now I know it's going to be 3 over 2. So I'm going to go ahead and count up 3, 1, 2, 3. And it's over to the right 2 because I'm going positive in both directions. Now, if I want to test and just check my work and do it in the other direction, the other way I can make this positive is if it's negative 3 over negative 2, because we know a negative divided by negative is actually positive. So these two actually represent the same slope, but it allows me to go in the other direction. So I'll go down 1, 2, 3 because I'm in the negative. I'm going to go to the left 1, 2. So there I can plot my other point and go ahead and insert my graph going through my 3 points. And like I said, you will be using a straight edge, so yours will be nice and straight, and that is what my graph will look like. All right, so that is the other way that you can graph using our slope-intercept form, and that is it for this video.